Now that you have gone through the family tree of quadrilaterals, I'm going to show you what those characteristics mean and how you're going to use that information to find measurements, whether it's a side measurement or an angle measurement. So first thing, I just want to refresh your memory on something that you guys did in Math 8. So if you'll bear with me, I am going to draw a set of parallel lines with a transversal line. So, when you guys were in Math 8, you had this setup and you learned about alternate interior angles, alternate exterior angles, you learned about corresponding angles, vertical angles, consecutive angles, all of those things hopefully are something that you recognize. Well, what I want to show you is that when we have this set up, if we were to take this side and just move it down and draw it again, what we just made is a parallelogram. So when we have a set of parallel lines with a transversal, you learned all that stuff last year. Well, basically that's what we're doing again, except now you can see that right in here we have ended up with a parallelogram. And we can actually end up with any of the quadrilaterals depending on what the angle measurements are. So if our transversal line was meeting the parallel lines and they were perpendicular, then we would be looking at a rectangle. If we had not only perpendicular lines, but we knew that the lengths were the same, we'd be looking at a square. If we had this shape, but we knew the sides were all the same, we'd have a rhombus. So we have a few different things going on depending on how, like what angle measurement this is, and how it intersects. So, but things that you learned last year in Math 8, like I said, you learned that, let's just say, just to make this look like what I'm about to say that it is, if we had something like, if this was, let's say this is 60 degrees, we learned last year that if this was 60 degrees, we know that this one would be 60 degrees. Well, if we turned our paper this way and looked at the parallel lines with the transversal, those were alternate interior angles, sorry, by the way. If we knew that this was 60 degrees, we know that this one would also be 60 degrees because those angles are corresponding angles. They're on the same corner, different intersection. So that's how we know that the opposite angles are congruent. We could also easily then figure out that along with this angle being 60 degrees, this one would have to be 120 degrees because together they make a line. That's also what we call consecutive interior angles. They're consecutive angles. They're the angles that are next to each other, but they're not congruent. They're supplementary, which is when they add up to 180 degrees. And so the same thing would happen over here on this side. So I'll make a little degree mark just to be accurate there. So that's something that we can tell easily. Something else that could happen is if we knew the measurement of this angle maybe was 60 degrees and maybe this one up here was 2x plus 5, we could easily make it into an equation. And so that's what I want to look at on the sides. Let's just say that you are told, and I'm just making this up, that this is 3x plus 8. Let's say this side is 2x minus 2. and you're trying to figure out what x is, you could easily do that. You know that these two sides are congruent, so you can just write an equation. So 3x plus 8 is equal in length to 2x minus 2, and then you could solve. So that could easily be done on there. Similar things with your diagonals. We talked about that a diagonal is when you connect a vertex with another vertex that isn't already connected. So that would be these two would make a diagonal, and then if we connected the other two, then our diagonals meet right here, and they bisect each other. So this side is equal to this side, and then this piece over here is equal to this piece. Now, they're not necessarily all four the same. That depends on what shape you have. In a parallelogram, since it leans to the side, we know that this one is going to be a little bit longer than this one because the shape is leaning that way. So, but things that could happen here, we know. Let me put some letters here. Let's say A, B, C, D, and we'll say they meet at E. We know that the length of DB is the length of DE plus EB. So we know that this piece plus this piece would equal DB. So that's just adding segments together. Segment addition is what we usually call that. But what we also know is that DB would equal 2 DEs. All right, or we can even say that DE would be half of DB. So there's a lot of things that are happening. So since those bisect each other, that creates situations in there. Other things, keep in mind that you know that we have vertical angles right there and right there. We have different triangles going on in there. So anytime that you can come up with an equation to help you solve something, that's going to be what you're looking for, is to write an equation that would help you solve something. Now, these triangles in here, we had talked about how those are congruent triangles and those are congruent triangles, but I want to quickly just remind you of what happens with a square and a rhombus. So let's see if I can. I'll try to draw a rhombus. I think I made it too long. Yeah, it's too long. Darn. Oh well, we'll just pretend that the four sides are equal. So we're going to say that this is a rhombus, but I don't think it really is, but that's okay. So we know that the characteristics of the parallelogram hold true for the rhombus, but we also have a few additional ones. And the one that I want to point out is what happens inside when we, oh yeah, this is a horrible rhombus right here, but we'll just pretend, oh my gosh, it's awful. But let's just pretend that when these meet, we're supposed to have 4 right triangles in there, okay? So what I want to mention about this is just like in the parallelogram, these bisect each other. So those two are going to be the same length, and those two are going to be the same length. But what I want to remind you of is what you know about a right triangle. So when we look at this, we'll pretend that that looks like a right triangle. Keep in mind that you know a certain very important theorem that you learned in Math 8 that applies to right triangles, and that is Pythagorean Theorem, that a squared plus b squared equals c squared. So that's something that can be very useful if you're asked to find the lengths of the sides of maybe the diagonals, or maybe you know the lengths of the diagonals and you're trying to find the sides of the rhombus. Just keep in mind that Pythagorean Theorem is a valid way to figure out sides on a rhombus or parts of the diagonal, lengths of the diagonal as well. So again, this is just to kind of reiterate that all of the characteristics that you learned from the family tree of quadrilaterals is going to go and help you with figuring out, missing angles, missing sides in here, angles, all those kinds of things. So it's probably a good idea to keep your family tree nearby so that when you're working through the problems in the section, you can refer back. And then just, remember the basics. If something bisects, it cuts it in half. If something's cut in half, that's 2 equal pieces. So 2 of these is the whole thing but divided by 2 is the 1, and so on. Keep in mind that triangles add up to 180 degrees. That's another one that is very helpful. So in this situation, we know that that one is 90. So if we were told what this angle was, we could easily figure out this one and the rest of them also. So you want to use your information, things that you have learned over the last year, plus all the characteristics of the quadrilaterals, to work together to find missing pieces.